I'm going to teach you guys how to create a proof. This is going to be tough stuff. You guys are going to have a hard time. Some of you will have a hard time with this, but I'm here to help you. Basically what happens is something is going to be given to us for this particular problem, AB equals CD. So I went ahead and marked those with the lines that lets us know that those are equal. And I want to prove that AC is equal to BD. I'm going to show you guys how to do that. So I'm going to write down some statements. I'm going to make what they call a two-column proof. I've got statements on one side, and I'm going to put my reasons on the other side. And my reasons are going to be what is going to be down in this chart down here. In this chart, once again, I'll give you guys during class, so you'll be able to have that with you at all times. So I'm going to look at this, and I'm going to try and figure out what are the reasons behind doing each one of these statements. So for my first reason, it's actually kind of nice, because if something is given to you, then the reason is going to be given. AB equals CD, and so that was given to us. I'm going to go ahead and type given there. Now the next one. BC equals BC. I'm going to come down here, and I'm going to look and see which one of those will help me. Which one of those is the reason? BC equals BC. Well, that's identical on both sides of the equation. And so I think that reflexive is going to be my reason. So I'm going to type reflexive property of equality. And that is the reason why BC equals BC. The next thing that happens is AB plus BC, so AB plus BC equals BC plus CD. And if you guys notice, I basically added BC to both sides. So I'm going to come back down to my reasons down here. And which one of these makes it so that I add the same thing to both sides? Well, the addition property, actually. I added C to both sides, so that's going to be what I do up here. I added the same thing to both sides. So this right here is the addition property of equality. If I can spell equality, that would help. Then, the next statement. I have AB plus BC equals AC. I'm going to come down here and see AB plus BC equals AC. Well, that's the segment addition postulate. If I have two segments and they add together to make a long one, then I'm using the segment addition postulate. So that's going to be my reason here. Segment addition postulate. Now I'm going to look at my next statement. This time I have BC plus CD equals BD. Same thing. I've got two small segments. When I put them together, makes a big segment. So that is also going to be segment addition postulate. Now we're on our last step. Why is this possible? Why can I say that AC equals BD? Well, let's look up here. I know that AB plus BC equals AC. And I have that same thing right here. So what I'm going to do is I'm going to scratch this out, since these are equal, and I'm going to put AC in its spot. And then it equals BC plus CD. Well, there's BC plus CD right here. So what if I scratch that out and I put BD in its spot? So when I do that, let's come down here for a moment. I'm doing the substitution property, because if A equals B, then B can be substituted for anything. So instead of saying AB plus BC, I can put AC in that spot. So the reason why I can do this is because of substitution. And that is our proof.